Actually, why does IPv6 come into existence when we have IPv4?
Like strong system.
Yeah,
Okay.
actually, IPv4 it is of 32 bits. Okay, and if we calculate it 2 power 32, at most we can have 4.32 billions of IPs. First thing, right? What do you think the population of world today?
Or
World
some
lived. How many devices do you have now?
devices from
I mean gadgets like laptop, mobile.
Amazon.
What
Like
do you have? You have one laptop,
yeah, all of
one
them.
mobile. That's it.
Yes.
Even I have one laptop, one mobile. On an average, every human today are having two devices, right? That instance, for suppose think that there are some 100 billion people into two 200 billion devices, and if every device wants to communicate with ISP, that instance you need 200 billion IPs. But actually, how many do we have? 4.32 billion, right?
Yes.
Then how to manage? Where is the equation between 4.32 billions and 200 billions? IEEE standard, they thought, the board has thought that 4.32 billions, it will not be sufficient in the future. So they, at that time only, they came up with a concept of natting, right? Natting. This is the concept where a private IP is changed into public IP. Okay, we usually do natting on the routers, the edge devices which are connected to ISP. Using this subnetting, somehow we are managing today, but in future, the technology may evolve more and more and more and more, and these IPs will not be sufficient. Okay, so they came up with IPv6, right? IPv6, where IPv6 has 128 bits. Okay, 128 bits. Any doubt?
Yeah, it's 64.
No, no, it's 128. Okay, it has 128 bits. Just imagine 32-bit has around 4.32 billion IPs. 128 bits. How many IPs can it contain?
Yeah.
Some it's we cannot speak that number in our general voice. Okay, so they came up with this IPv6, right? So that is the thing. In 1992, an impending shortage of IPv4 address space was first recognized in 1992. In 1994, IETF launches work into IPv6. They started work on IPv6. IETF. It is an engineering and technical forum which does this research and gives standards. Okay. In 1998, first RFC was introduced with the number 2460 for IPv6. It was written. First RFC was written when into 1998. In 2006, the stabilized version of RFC was implemented, and 2008 in 2008 US federal government mandates IPv6 compatibility of all backbone devices of federal agencies. In 2008, they made it mandatory to make all the backbone devices need to work on IPv6, which US federal government when in 2008. And in 2015, ARIN, it's an American registry for IPs, runs out of IPv4 addresses. This is the thing why IPv6 has come into existence. This is the history and introduction. In the introduction, see 128 bits addressing system. IPv4 is 32 bit. This is 128 bit. This is expressed in hexadecimal instead of decimal. While IPv4 we write in decimal format, but we write this in hexadecimal. And IPv4 we denote it with dotted decimal, but this it will be denoted with hexa. This is sorry semi. This is a colon, right? And 4 bits equal to 1 hexa character. Hexadecimal you know right? Hexadecimal. Hexadecimal 1 character is equal to 4 bits. And for example, the example of IPv6 address is this is. See, every portion has 4 hexadecimal digits, and every hexadecimal digit equals 4 bits. That instance, 4 bits into 4 hexadecimal digits, that is 16 bits. 16 into 1 2 3 4 5 6 7 8 8 into 16, 128 128 bits, right? So headers, what is the difference between IPv4 and IPv6? In IPv4 we have version, similarly in IPv6 also. Here we have internet header length, you don't have it. You have type of service, same here, traffic class, right? Here you have total length, right? Here you don't have any total length. You have identification. I told you yesterday, identification. What is the requirement? Flow label is the identification of the as it works in IPv4 identification. How it works in IPv4? In IPv6 we have flow label. Here you have total length. Here you have payload length, right? Next header is very similar to protocol. Protocol, I told you, when device sees in IPv4 header, when it sees protocol field, it will come to know to which head upper layer protocol should it give this data, right? Yesterday we have discussed it.
Yeah.
Once after going home, you just revise that video, okay? And similarly in IPv6 we have next header, right? We discussed TTL also. Yeah, the hop limit in the IPv6, and this source address, destination address, source address, destination address. This is the IPv4 and IPv6 difference. Everything is same, just here you have more fields. Here we don't have it.
Yeah. Some much.
Yeah. An introduction to IPv6. So here IPv4 host address. When you give an IP to the host, as I told you already, you will have two parts, that is one network part and one is host part. So here the network part is 20 20 20 and the host part is 3, right? In IPv4. Similarly in IPv6 we have the same. See, for example, this is my IPv6 IP, right? Version 6 IP. Okay, here this double semicolon means that in between this field, here in this field, between this field and this field, this means that all the zeros are included. Okay, and similarly we have here network part and host part. In the IPv6 we have network portion which is prefix, and host part will be interface ID. It is not host part, it will be interface ID. In IPv6 we call it as interface identifier, interface ID. Okay, so this is my IP actually. This is my network ID. How do you come to know about network ID? Because as we use here 24 as an value which represents what is subnet mask, in IPv6 we have this thing. 64 tells up to how many bits the network ID consists. And yeah, as it is 64, 16 plus 16 plus 16. So this is network. Then remaining 64, out for the remaining 64, ultimately 64 are network bits. Out of 128, 64 are network bits. Then the remaining 64 bits will be the host port, will be the host bits, right? Same. Then the remaining 64 bits are, actually this is 48, and the next 16 will be zeros, right? 16 plus 16 plus 16, 48, plus 16, 64, and here 16, 16, 16, 16, and this will be the interface ID. It is host part. As in IPv4 host part, here we have identifier. This can be derived automatically, dynamically. It can be derived by the PC itself, or we can do it manually. Okay.